Hello guys, you are welcome back to my channel Structures Pro. Today's class will be doing foundation design. We started this structure from beginning and today we'll be doing foundation design. The first thing to do is we run analysis again. Each time you close your start work and reopen it before you can do anything, maybe connection design or foundation design that requires design information like reactions, member forces, you need to still run analysis. Without running analysis, it will not work. So we just run analysis. When the analysis is done, we proceed with the foundation design. So I will still beg you at this point, if you have not subscribed to my channel, please click the subscription button, like and share. Give me a positive comment. Thank you. Okay, the analysis is done. So we just click done. Then you come to this side, see foundation design. We have foundation standalone, yes, but me, I prefer using this foundation design. This will take you to that foundation standalone. So they are the same thing. Just as we have connection design as well, we have connection design standalone. So it's either you go to that standalone, which has its own icon on the desktop, you open it and do your connection design there, or you click here and it takes you to that place. So me, I like using all this one because it takes the reactions you have from your analysis to that environment. So you don't need to start typing in your forces or any information again. So I'll quickly click on foundation design. Then from here you choose the load combinations. So I'll choose the serviceability and the ultimate, the two of them. I'll say include. If you click include all, it will include all including the primary loads, to include all. So I will exclude all and reselect. Select all the combination load cases. Yes, include. And I will say I'll click on foundation advanced. I'm using advanced foundation. It's very advanced. So it's taking us to foundation design. Let's wait for it to load. Yes, it's up. So it has given me two options, either to use the start foundation advanced or to use the just StaadPro limited feature. So I'll click on this and say okay. It's coming up. Yes, we have launched it, but it's still loading. Sometimes it takes time, takes little time. You just exercise some patience while waiting for it. Yeah, it is done. So these are the 4 legs of the water tank stand. So the first thing to do is to need to create a new job. So we come to this place, we type in the job name. I can use water tank stand foundation. It is selected, put in. If it is not selected, you select the one it is. Like here you have pile cap, mat, combined, octagonal, strap. So my own is isolated. From here, design code, you choose the design code. If it is US, British, Indian, Australian, Canadian, Euro. So I want to use US. Under this you have the codes, and then the units. I want to use system international unit, not English. Assigned to all supports, yes. Then here I will include all the load cases, load combination. I'll click select all the load combinations. Then I'll click on create job. You see, water tank stand foundation has been successfully created. You say okay, that's good. So I will now go and I'll start imputing my values, the input parameters. So the first one under it, okay, you see the isolated footing I created. This is it. So these are the design parameters. Go to concrete. Say okay, unit weight of concrete, of course, is 25. Some use 24, but I use 25 kilonewton per meter cube. Minimum bar spacing 50 mm is alright for me. You can change it. Maximum bar spacing, maximum 150. You can put 200 or 250 or 300 there. Maximum strength of concrete, use 25 Newton per meter square. Yield strength of steel 410, yeah, is alright. Minimum bar size, minimum, I will change this one, can use 10. Maximum bar size footing bottom, maximum, can use 16. Minimum bar size footing top, this one will not be necessary, that won't be a top reinforcement, but we'll just put values here. Minimum pedestal bar size, minimum, I use 10. Maximum pedestal bar size, I use 16. Pedestal tie bar size, tie, I use 10. Minimum pedestal bar spacing, minimum, okay, 75 is okay. Maximum pedestal bar spacing 200. Set as default. You can choose to set it as default. This one will help you that in such a way that the next time you are coming here to do another design, you will just see all these figures the way they are. So you simply go to the ones you need to change and change them. That's the essence of setting it as default. Then we go to cover and soil. Pedestal clear cover is 50. Okay, 50. Let me use 50. Bottom clear cover is still 50. Unit weight of soil, and this one will come from a geotechnical survey. If they have to specify the unit weight of the soil at the area you want to put up the structure. Base value of soil bearing capacity, it also comes with geotechnical information. So maybe I can put anything according to the geotechnical reports. If the soil is good enough, you can have a bearing capacity of 200, 250, 300 sometimes, 150. But if the soil is poor, you can be seeing like 25, 50 or so. So let me just use this for this class. Let me use 200, assuming the soil there is okay, is firm enough. Multiplier on soil bearing capacity, this is the factor of safety. It can be 3, it can be 2.5. Let's use 3. Depth of soil above footing. Depth of soil above footing. Okay. The soil above the footing. So I plan to bury this footing down to 1 meter. So if I take it down to 1 meter, and maybe the footing thickness is about 200 or 250, what is left out of 1 meter is about 750. Okay, it's okay for me, 750, so that when I include 250 of the footing, I'll have 1 meter depth. I'll go with this. Then surcharge pressure, I don't need surcharge pressure. Depth of water table. So from survey information, geotechnical report, you have the water table, whether the water table is far below the foundation footing or is close to it. This one will help us to determine the upthrust, the uplift. Yes. So let me say 0. Let me use 0. Water table, let it be 0.4 meters. Yeah. Okay. Then from geotechnical reports can get the angle of internal friction, but this our soil pressure will handle every other thing. Go to sliding and overturning. Coefficients of friction, yes. Factor of safety against sliding 1.5. Factor of safety against overturning 1.5 is okay for me. Now the next thing I will do is I'll go to footing geometry. I jumped it, sorry. Footing geometry, yes. Minimum length of footing, 1 meter by 1 meter is okay for me. Minimum width 1 meter. Minimum thickness, let me use 200 here or 250. Yes. Maximum length 3000 by 2000. Okay, let me leave it. I can change it to 25. Let me change it to 2500 by 2500. Maximum thickness, let me use 250. I want the thickness to be 250 actually. Okay, these ones are good, and you can set to as default. Yeah, then the next one is we need to now batch our loads to tell the software which one is our primary load and which one is our serviceability limit state load combination and which one is our ultimate limit state load combination. So we'll quickly do that. We'll come to load, click on load, then we highlight all the allowable stress load combination, which is the same thing with serviceability load combination. This once we batch it, the software will use the serviceability to do the footing sizing, then use the ultimate to do the member design. But if you don't batch, if you don't do this in your foundation design, the software might just take the ultimate limit combination to do your footing size, and at the end of the day you'll be having a massive footing. Yeah, so that's the reason for this. So we quickly highlight to this point, hold down your shift key and click on this one. Everything is highlighted, so we specify it as service. We batch, apply, then we select the other one, which is strength. Strength starts from here down to this place. We click ultimate, batch. That's good. Yeah. Then another thing is we have to specify the pedestal. So we come here, let me minimize this one, click on foundation plan. Yes, click on pedestal and anchor bolts. So for here now we'll put yes. Okay, it's already on. We want pedestal, so pedestal height, we can use 2 meters. So if we bury about 1 meter in, 1 meter will be projected. Okay, let me use 1.5. So 500 will be projected. 1.5. Can copy this one. Control C, Control V, Control V, Control V. So the pedestal length and width is 500 by 500. So it's okay by me. I like it like that. So I'll close. Then I'll click design. Yes. Do you want to analyze? Design? Yes. So okay, save as. You can save as if you want to save it somewhere in your system. You save it and name it, but I don't want to save as. I'll click on save, and the design will start immediately. Let's just give it time. Again, I also like to remind you, if you have not subscribed, don't be watching and be enjoying yourself alone. Also encourage me by subscribing, like and share, comment, tell me how you feel about the class. Make your request if you wish, if you want me to do something for you. If you have a request of a tutorial, I can as well do it and post it on my channel. So subscribe, like and share with your friends, your colleagues. If you have missed my previous classes, I'll urge you to check my channel, enter into my channel. You will see a lot of videos about this tank. I actually started from beginning to end. This is foundation. In my next class, I'll be doing connection design. So I want to finish everything about this water tank stand. So if you have a similar project, you don't have any worries, just come here in my channel, watch from beginning to end. All the information you need, you get all. I took my time to treat everything from beginning to end. Yes, the design is done. Let's check the output. Okay, you see this one is isolated footing 1. If you come here, you have 4 footings there. So this report showing here now is for this footing 1. You can change it to check footing 2, likewise for 3 and 4. You have 0 warning and 0 error, so everything is fine. In fact, if we have any, if the design does not pass, you won't get here. We won't get to this output result. We won't have any output. So for us to have output means everything passed, everything is okay. So if you check this footing, is giving us a 2.4 meter by 2.4, and the thickness is 0.25. So you see the reinforcement, 9 numbers of 10 mm by 9 numbers of 10 mm. So there is no requirement for there is no need for top reinforcement. So this is just the sketch by the software. Everything is all right. The thickness of the foundation is 0.25. The height of pedestal is 1.5, as I put it there. This is just an elevation of it, kind of section. This is the pad itself. You see 2.4. The pedestal is 0.5 by 0.5. Correct. So the input values are these ones: column dimension, design parameter, concrete and rebar property, sliding and overturning, the footing size as input. For the allowable stress load combination, because we batched our load, that's why he was able to recognize that this is allowable serviceability. So this is the output. If you browse through, you see a lot of information. This is the design size of the footing. This is the pressure at top left, which is less than the bearing capacity. Yes. See overturning and sliding check. Everything is okay. Minimum sliding ratio for the critical load case 2.9, which is greater than 1.5. Very good. Everything is all right. Perfectly okay. Perfectly okay. Everything is okay. Everything is well. Okay. So this is the report. To simply print this report, okay, there is another one that you can see material takeoff for the footing reinforcement, for the pedestal reinforcement, then concrete, then formwork, soil excavation. Everything is complete. With this software, you don't have any problem as an engineer. It does everything for you. That's the need for you to learn it. For you to keep learning, I will urge you to subscribe. Pause now and subscribe. Just give it 2 seconds and subscribe. Click the subscription button and like and share. Click the notification button so that whenever I upload any new video, any new tutorial, any class, you'll be notified. So for us to print this report, simply click on print calculation sheet. So from here, is either you send to printer or you convert to PDF. So this is my PDF here, PDF redirect. I'll click print. So it's printed already, so I'll just name it here and save it in any folder. Once it's saved, you see it as PDF. It becomes a PDF a file. So if you double click, you see it as a report. It just is a report, foundation report. So with this software, you don't need to stress yourself. It does everything. This is the geometry, the detailing. See the detailing. You can as well export this to AutoCAD. If you want to start your drawing from here, export it to AutoCAD, then dust it up, clean it up. CGA, general drawing, the footings. All of them don't have equal. This one is calculation sheet. We have graph. So we end here. Stay tuned for my connection design. Is coming up. Or depending on if you are not watching this day, July 2022. Check for the connection design is already in my channel. Go and click and watch all the videos in my channel. They are all educative. They have a lot of information inside. You have a lot to gain in this channel, so I still beg you to subscribe. Your subscription is my encouragement. Subscribe, like and share, then click the notification button so anytime I post a video, you'll be one of the first people that will be notified. Thank you and thank you. Meet you next time.